So our next example, let's look at it, is to calculate the volume of gas that will be produced at the electrodes. When we talk about electrodes, we mean the cathode and anode. When 0.05 mole of electrons are passed through a dilute solution of tetraoxosulfate 6 acid. Wow. So this is another form of question that had to do with Faraday's first law. So we are looking at this time around not to calculate the mass of a metal deposited, but this time we are told to calculate the volume of gases that will be liberated at the cathode and anode when we have electrolysis of acidified water. So we said it from the beginning when we started talking about electrolysis that when we pass electricity through a solution of sulfuric acid, that is sulfuric acid dissolved in water, it is called electrolysis of acidified water because the water has been mixed with an acid. So we are told here that electrolysis of acidified water is being carried out, and as a matter of fact, gases are produced at the cathode and the anode. Now, when 0.05 moles of electrons are being passed into a solution, we are asked to calculate the volume of gases that will be liberated. And we are told that hydrogen is 1, which we know, the RAM for hydrogen, and molar volume is 22.4 dm cube. From our knowledge in stoichiometry, we know that the one mole of any gas will always occupy 22.4 dm cube. So let's proceed to looking at how this question can be tackled. We can put our calculator over there, and then let's see how to go about that. So we have 0.05 moles of electrons passed, and our acid is sulfuric acid. So when sulfuric acid, when we have sulfuric acid being electrolyzed, it's going to split this way. This is what happens. So sulfuric acid will split into hydrogen ions and SO4 ion. Of course, it is sulfuric acid in water. So we also have this. So this is what we have. Hydrogens proceed at the cathode. SO4 2 minus and OH minus move to the anode. So at the cathode, hydrogen will be liberated. At the anode, we have seen that oxygen will be liberated. So there is no need going about doing the equations again. We just know that at the cathode, hydrogen will be liberated there. We have seen that before. And at the anode, oxygen will be liberated at the anode. But we only have to go ahead to write out the equation this time around, since we are talking about calculations. So how is the equation written? Since we are told 0.05 moles, electrons passed is 0.05 moles. 0.05 mole. So let's proceed. Now for hydrogen, we know that since it has to do with 2 ions, then it means for hydrogen to be liberated at the cathode, it will need 2 electrons to be liberated as hydrogen atom. And hydrogen atoms now combines with other hydrogen atoms to give us hydrogen molecule. So what it simply means is that 2 moles of electrons led to the deposition of 1 mole of hydrogen. That is 2 Faradays liberated 1 mole of hydrogen. That's just what it simply implies. So for hydrogen here, we can say that 2 Faradays or 2 electrons, 2 moles of electrons, has given us 1 mole of hydrogen. That is just what we can say. Has given us 1 mole of hydrogen. 1 mole of hydrogen gas. 1 mole of hydrogen gas. Hydrogen as a gas. And what is 2 Faradays? 2 Faraday is 2 times 96,500 coulombs. So we may go ahead with that. So this is 2 times 96,500 coulombs. Has given us 1 mole of hydrogen gas. And 1 mole of hydrogen gas is 22.4 dm cube. 1 mole of hydrogen gas by volume occupies 22.4 dm cube. So we can say that 2 times 96,500 is 193,000. 193,000, we have seen that before. 193,000 coulombs of electricity has given us 22.4 dm cube of hydrogen from the equation. Now what about for oxygen? To go about for oxygen, this is what we do. At the anode, the equation at the anode is OH will be liberated at the anode, and this is how the equation is written. OH will be liberated to give us water plus oxygen and 4 electrons. So for that to happen, it must be balanced with 4 electrons. So what this simply implies is that 4 moles of electrons has led to the deposition or liberation of 1 mole of oxygen gas. If you look at the equation, it is balanced because we have 4 hydrogens, and at the left hand side there are 4 hydrogens, and at the right hand side also we have 2 oxygen plus another 2 oxygen. That is 4 oxygens. And at the left hand side too we have 4 oxygens, as you can see here. So this 4 is for both hydrogen and oxygen. So the equation is balanced. So what it simply means here is that 4 moles of electrons, or 4 Faradays, has led to the liberation of 1 mole of oxygen. Look at it, oxygen as a gas has led to the liberation of 1 mole of oxygen. So this is how the expression for the liberation of oxygen gas at the anode is being done. So what do we need to say then? What we simply need to say therefore is 4 moles of electrons, or we may say 4 Faradays. So 4 Faradays of electrons has given us 1 mole of oxygen. 1 mole of oxygen. 4 Faradays of charge has given us 1 mole of oxygen. Or we may say 4 moles of electrons has led to the liberation of 1 mole of oxygen gas. Oxygen gas. So what is 4 Faradays or 4 moles of electrons? 4 Faraday is, by value, it is 4 times 96,500, because 1 Faraday is 96,500. So it means that 4 times 96,500 has given us 1 mole of oxygen gas. And what is 1 mole of oxygen gas? 1 mole of any gas at STP, from our stoichiometry knowledge, is 22.4 dm cube. 22.4 dm cube. So what is 4 times 96,500? We can do that. 96,500 times 4 gives us 386,000. So 386,000 coulombs has led to the liberation of 22.4 dm cube of oxygen gas. But 193,000 coulombs of this charge has led to the liberation of 22.4 dm cube of hydrogen gas. But we are told that the quantity of electricity, or rather the mole of electron that was passed, is 0.05 moles. 0.05 moles of electrons was passed. So when we talk about moles of electrons, we still make reference to charge, because electron has to do with charge. When electrons flow, it is charge that is flowing, because they flow as electricity, currents of electrons. So from the equation here, 193,000 coulombs gave us 22.4 dm cube. That is from the normal equation. For oxygen also, 386,000 coulombs gave us 22.4 dm cube of oxygen gas. But from the question, we are told that the quantity of electrons, or if you may wish to say charge, that flowed into that acidified water is 0.05 mole of electron. So what we simply need to ask ourselves is, what is the value of 0.05 moles of electron? What is the value for 0.05 moles of electron? So to know what 0.05 moles of electron is we know that 1 mole of electron is equivalent to 96,500 coulombs, 1 mole of electron. So what about 0.05 moles of electron? What will it be? That is just what we need to know. So since we already have seen the quantity of charge that produced 1 mole of hydrogen and 1 mole of oxygen, what we need to do is to say, already we know that 1 faraday, or you may wish to say 1 electron, 1 mole of electron, is equal to 96,500 coulombs. But from the question, 0.05 moles of electron was passed. So by value, what is the value of 0.05 moles of electron? That's all we'll just say. So 0.05 moles of electron. If 1 mole of electron is 96,500 and 1 mole of electron is the same thing as 1 mole of Faraday. So we can say 0.05 moles of electron or 0.05 Faraday. What will be its value? X. We have to calculate its value, X. So simply we'll cross multiply this times this, this times this. So we are going to have 1 mole of electron. Let's write it like that. 1 mole of electron times X is equal to 96,500 times 0.05. So 1 mole of electron times X is still X. That is 1X. Is equal to 96,500 times 0.05. What will it be? 96,500 times 0.05. What will it be? It gives us 4825. So it means that the quantity of electricity that was passed into that acidified water is 4,825 coulombs of electricity, which is the same thing as 0.05 moles of electron. Just like here, if I don't want to say this is 386,000 coulombs, I can simply say it is 4 moles of electrons or 4 Faraday. If I don't want to say 193,000 coulombs of electricity, I can simply say this is 2 moles of electrons or 2 Faradays. So we can see that. I just want us to get it clear. So 0.05 moles of electron by value is 4,825 coulombs of charge, because electrons constitute this electricity. That is, the flow of electrons constitutes this electricity we are talking about. So that is actually what we are saying here. So I just want us to understand the value of 0.05 moles of electron. So in value, 0.05 moles of electron is equal to 4,825 coulombs, just as 4 Faraday or 4 moles of electron is equal to 386,000 coulombs of electricity, and 2 Faradays or 2 moles of electrons, as we can see for hydrogen here, 2 moles of electrons or 2 Faradays is equivalent to 193,000 coulombs of electricity or charge. So this is actually what we should know. Now, we have seen that from equation, 193,000 coulombs of charge will liberate 22.4 dm cube of hydrogen. But from the question, we were told that 4,825 coulombs of this charge or electricity was passed. So what we need to now know is what will be the volume of hydrogen this value 4,825 coulombs will give us? From our normal equation, 193,000 will give us 22.4. From the normal equation, as we can see there, 193,000 coulombs will give us 22.4 dm cube of hydrogen. 22.4 dm cube of hydrogen. So what will 4,825 coulombs of that quantity of electricity give us? What volume of hydrogen will it give us? That is what we just need to do. So by the time we cross multiply, we have we're going to have 193,000 times x and 4,825 times 22.4. That's just what we're going to have. So when we do that, we have 193,000 times x will give us 193,000 x equal to 22.4 times 4825. So let's do that. 22.4 times 4825. That gives us 108080. So we're going to have 108080. So to get our volume of hydrogen that will be liberated, which is the x, is to say divide both sides by 193,000. Divide both sides by 193,000. So 193,000 can take care of 193,000, and our x, which is the volume of hydrogen now that will be liberated in dm cube, will be 108080 divide 193,000. Our answer is 0.56 dm cube. That's as simple as that. So our x is 0.56. Sorry about that. 0.56 dm cube. So the volume of hydrogen that will be produced at the cathode by this 4,825 coulombs of electricity, or you may wish to call it 0.05 moles of electron, 0.05 moles of electron is, this is the value of hydrogen that will be produced by that value of electron. 0.56 dm cube of hydrogen will be produced, because from normal equation 193,000 coulombs of electricity will give us 1 mole of hydrogen, and 1 mole of hydrogen from our stoichiometry knowledge is 22.4 dm cube. So what 4,825 coulombs of electricity will give us is 0.56 dm cube. That is for hydrogen. Now let's proceed to oxygen. Let us know, because the question says we should calculate the volume of gases that will be liberated at the electrodes. That is the cathode and the anode. So we have seen that for hydrogen. Let's look at that for oxygen. For oxygen, 386,000 coulombs of charge produces 22.4 dm cube of oxygen from its normal equation. So, but because 0.05 moles of electron was passed into the solution, what volume of oxygen will it give? And 0.05 mole of electron is equivalent to 4,825 coulombs. So let's relate that now, just as we have done for hydrogen. So in the case of oxygen now, 386,000 coulombs produced 22.4 dm cube of oxygen. We produce 22.4 dm cube of O2, oxygen gas. So what about 4,825 coulombs? What will it give? What volume of oxygen will it give? X in dm cube. X. Because this is the moles of electron that was introduced, we were told. So it is good we get it straight. Let's not get it confused. So let's proceed. Now, to know the volume of oxygen that will also be liberated is to cross multiply. So let's cross multiply. 386,000 times x, then 22.4 times 4825. That's how we cross multiply. So cross multiplying, we have 386,000 times x will give us 386,000 x equal to 22.4 times 4825. So this will give us 386,000 x is equal to 22.4. Let's do that. 22.4 times 4825. That gives us 1080, which we did before. 1080. So to get our x is to divide both sides by 386,000. 386,000. So we have 386,000 take care of 386,000. Therefore, our x will be 1080 divide 386,000. That's what we should do next. 1080 divide 386,000. That gives us 0.28. So our x will be 0.28 dm cube. So the volume of oxygen that will be produced is 0.28 dm cube, while the volume of hydrogen that is going to be produced at the cathode side is 0.56 dm cube. Now there is something very interesting about this calculation we've just done. If we compare the value of hydrogen produced and that of oxygen produced, we'll see something striking about it. Let's compare them. This is it. Comparing the volume of oxygen produced at the cathode and the volume of hydrogen produced at the the volume of oxygen produced at the anode and the volume of hydrogen produced at the cathode, we'll observe that the volume of hydrogen is 2 times the volume of oxygen. Look at it, 0.28. When you multiply it by 2, it gives you 0.56. Can you see that? So it means that, just as we have said from the beginning, in the electrolysis of acidified water, the volume of hydrogen is always 2 times the volume of oxygen. The volume of hydrogen is always 2 times the volume of oxygen. So this is actually a confirmation of what we have just said. So we can see that from the question, the volume of oxygen liberated at the anode is 0.28 dm cube, while the volume of hydrogen liberated at the cathode is 0.56 dm cube. So it tells us that the statement, or rather the experiment for hydrogen and oxygen using when we carry out electrolysis of acidified water is actually correct. The volume of hydrogen is always 2 times the volume of oxygen, and that is actually what it should be. Okay, so we have seen example 4.